Mini Vision Sensor VDS10 series. Now we can connect Ethernet cable to the computer. Then we can start to debug. We can set up the sensor in a specific position with a jig available and make sure the sensors will not be moved during the debugging. Then open the folder MJAI Sensor. Double-click the application of MJAI Sensor. Then we will be able to obtain the info of the sensor. The sensor requires us to configure the IP of the sensor for the first connection to any new devices. In IP configuration interface, there are two setting modes available. We need to use static IP and then click one key matching button. By doing so, below four options will be activated: IP address, subnet mask, default gateways, and DNS server. To connect the sensor, for example, we can edit the last segments of the IP address, as well as those of gateway and DNS server. There's no need to change the address of subnet mask. Then we can confirm the settings. After the confirmation, the status of the sensor will be turning into available. Then we will be able to manage the sensor. Let's take a look at project management. To add a new project, we have to go through 4 steps: camera, template, tool, output. First of all, camera. We can adjust the brightness and white balance automatically and manually. The auto adjustment will take both the influence of ambient and external light source into account during the adjustment. Click Auto Parameter. The sensor will adjust brightness and gain automatically. As I turn down the exposure time, the brightness of the picture is obviously decreased. After the camera is fully set up, we can move to step 2. Here we will add an object as the template, so the subsequent detection can count on the template we build up. Please hold the camera steadily and don't move the sensor. We will have correction tool and location tool available in the tool settings. As the correction tool do not output any detection results, we use location tool more frequently. We will be able to find pattern, blob, edge, circle, and collinear by using this tool. Take find pattern for example. We will be able to set the detection area and space. We can also set up the imaging sensitivities and similarity accordingly. As we put the template into the detection area, the image acquired shows us many green dots. These dots are seen as the features of our model and will become the basis of the following detection. We can also specify detection range to increase the imaging range and filter out those images with high similarities by increasing the value of similarity. Furthermore, the angle tolerance allows us to capture those images that can be misplaced or placed upside down. Step 4. Output setting. The camera supports I/O function. We can set up the I/O output and the result output when we use Ethernet or serial ports to transmit data. Finally, confirm the setting and then run the project. No matter how we rotate the object, the camera can always output an OK result. For the usage of Find Blob, we return to Project Management Interface and repeat above Step 1 and Step 2 to enter the interface of Find Blob in Location Tool. First of all, specify the search area and then featuring the template by adjust the grain threshold. For example, 0 stands for black, 255 stands for white, so we can increase the grain value to the middle parts of the value bar to recognize the presence and absence of a blob. We can also specify the detection content by increase or decrease the area range, which work as a filter tool. It can help us filter out interference. Image setting. We need to save the image after the acquisition. We can open the image setting, where we will be able to access to the folders that images are saved.